Welcome to Control 4 Driver Development Essentials. My name is Peter Casenza. In this video, we will walk you through the steps required to create a Control 4 driver for an IP camera. In doing so, we'll use two tools delivered by Control 4 to assist with driver creation. The first is Driver Editor, a driver development environment that provides a graphical interface to modifying existing C4I files or create new ones. The second is a Control 4 driver template. Control 4 is delivering driver templates for many of its more heavily used proxies. When a driver template is loaded into the driver editor environment, it offers a powerful development scenario that can help reduce development time as well as improve code quality. In this video, we will use a template specifically designed to help quickly and efficiently create camera drivers. In viewing this video and the remaining videos found in the T201 series, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T101 video series. You may find it useful to review the information offered in those training modules before proceeding to develop template-based C4I files. This video is designed to be viewed in two parts. The first section, or Part 1, provides a concise set of instructions on how to modify the Control 4 camera driver template to connect to a camera and consequently receive an image from that camera. Its purpose is to instruct you on how to use the template in an efficient manner and end up with a base level camera driver which can be used as is or enhanced further. The second half of the video, or Part 2, will use the driver code configured in Part 1 as a foundation for enhancing the code to support more advanced camera functionality such as panning, camera tilt, and zooming. Before we start creating a camera driver, a few considerations need to be made with regards to the external resources you'll need to successfully complete your development. The first is obtaining the protocol documentation for the camera with which you will be working. This information is typically available from the camera manufacturer. The other information you'll need is a list of approved URLs that you can use to test your camera driver. These URLs can also come from the manufacturer and in fact are preferable. URLs will be needed for all of the image formats you would like to support through your camera driver. By default, the camera template supports URLs for JPEG, Motion JPEG, H.264, and H.264i, also known as interleave mode. With this information in hand, we can get started with Part 1 of creating a template-based camera driver. From within Driver Editor, we'll select File and hold our mouse over the New menu option. Here we can see the templates that are currently available to us. Here is our camera template. Double-clicking on it will load the template into the Driver Editor environment. When the template has finished loading, the main screen is displayed by default. We want to make some high-level changes at this point that involve the naming of our driver, copyright information, and so on. The camera for which we'll be creating a driver in this video is the Panasonic WV-ST165. So we'll change the manufacturer and model fields to reflect that. Next, we'll name our driver. This entry is important as it will be displayed in places where users will be looking for our driver. A driver name should be descriptive and informative. We'll name this driver Panasonic IP Camera WV-ST165. These fields are important as they will be used to search for and find the right camera in Composer. We'll leave the creator value unchanged for our purposes, but this entry could be a developer name or company name. While we are in the main page, let's update the copyright information. Next is the version field. Since this is the first iteration of this driver, we'll leave the version at 1. However, you can start your versioning as you see fit. We can also update the created entry. This is useful as it provides a date stamp when our driver development was initiated. You can modify the time and date elements by highlighting each and using the arrow buttons. You can also set the field to the current date and time by clicking on the clock icon. The modified field functions similarly to the created entry and offers you a way to assign a time and date stamp to further driver modifications. We'll set our modified value the same as our created entry. You can also set the modified date element on a system-wide level under the Options menu. Select Preferences, Export/Import, and then Dates. Here, you have 3 choices for how the modified date field will be populated. Manually, as we have just demonstrated. On saving a driver, the modified field will be updated. Or you can choose to have the field updated upon exporting the driver. Those are all of the changes we need to make to the main page. All of the remaining values are set correctly by default for us from the camera template. At this point, we've configured all of the high-level information for our driver. Next, we will take a look at the Proxies tab. We see that the camera proxy is already added for us, so there is nothing more we need to do here. When we open the Capabilities tab, we see that there are entries for all of the capabilities supported by the camera proxy. We will cover these capabilities in detail in Part 2 of this video. For now, just realize that when testing the basic driver at the end of Part 1, the pan, tilt, and zoom controls will not be available in Composer Pro or devices running Navigator due to the false values entered in the has pan, has tilt, and has zoom capabilities. Next, we will take a look at the Connections tab. You will notice that this template contains 2 connections. Technically, only one connection, the proxy connection, is required for a functional camera driver. This proxy connection in our template is named Camera. The second connection you see, named Camera Connection, is a network connection. This is included for more advanced development techniques, including Control4 SDDP support. For the purposes of this training video, all you will need to do is delete this connection by right-clicking and selecting Remove Connection. Now, let's move to the Codes Commands tab and modify this template so we can receive an image from our camera. When we open the Codes Commands tab, we're presented with the Lua portion of the camera template. In the introduction to this video, we indicated the need to use valid testing URLs. Here is where they come into play. We will include the URL for obtaining a JPEG from the camera by storing it in a local variable named snapshot query string, which can be found in the UIREC getSnapshotQueryString function. We will replace the sample text between the quotes with our valid URL. In this particular template, this variable declaration can be found on line 120. If you are using a different template, simply do a string search on the function name to locate this line of code. It is important to take a moment and discuss the components of a URL and which pieces we need to include and which ones we need to remove. Here is what our original URL looks like. In order for the template to use the URL, we need to remove the following pieces: the HTTP, the IP value or host name, and the port number. Now we have a string that looks like this. We need to take this string and place it into line 120 so that it looks like this. Now, let's take a look at line 136. This is the line of code that we need to modify to include the URL for our motion JPEG signal from our camera. Again, we'll need to strip off the unnecessary pieces of the URL and add it as follows. If we scroll down to line 144, we'll find our template entry for the H264 URL. We'll modify the code just like we did in the two previous examples. At this point, we've modified the camera template to an extent where we should be able to load our newly created camera driver into a Composer Pro project and obtain images from it. We'll need to configure some settings within Composer Pro, but at this point, we should save our driver. To do so, click File and Save. Now that we've saved our new camera driver, let's load it into Composer Pro. With Composer Pro opened, click on Search under the Items area on the right-hand side of the screen. We can narrow our search by selecting the device type and manufacturer. Double-clicking the driver will add it to our project. Now that the camera is added, we'll need to identify it. To do this, we'll go to the Camera Properties page. We'll enter the camera's IP address in the hostname IP address field and click Set. You'll want to verify the rest of the address content here as well. The authentication section of this screen allows you to set up a username and password for accessing this camera at the Composer Pro project level. For our testing purposes, we'll leave this blank because the driver is not yet configured to require authentication. To verify connection with the camera and the URLs we added to our template, click on the Camera Test tab. Here we can see buttons to obtain a snapshot URL, a motion JPEG URL, as well as an H264 version. If you click on the Get Snapshot URL button, you can see that the field below is populated with a test URL. If we click the Test button, Composer Pro will test the URL values that we included in our camera driver. The status of the test is displayed in the window at the bottom of the screen. Let's also test the motion JPEG and H264 URLs as well. All of our tests have passed. This means we can access the camera from within Composer Pro and see sample images for each of the formats. To see the images from the camera, double-click on the camera from within the project tree. Here we can see the snapshot image, a motion JPEG stream, as well as an H264 version. Likewise, if we refresh our navigators, the image streams will be available under the Securities area on devices running Navigator. This completes part 1 of the camera driver development video. You may wish to stop the video at this point and use what we've just demonstrated to create your own camera driver. Part 2 of this video will address ways to enhance this driver even further. We'll examine how to modify the template to control features that our camera can support. These include panning, tilting, and zoom. Before we move on, let's take a moment and review what we accomplished in the first half of this video. We loaded the camera driver template into Driver Editor. We updated the main tab with pertinent information regarding the camera for which we are creating a driver. Then we went into the Codes and Commands area of Driver Editor and added URL information to our driver that would allow us to view images from the camera when loaded in Composer Pro. At this point, we have created a functional IP camera driver. Cameras come with numerous feature sets, and chances are good that you'll want to create a driver that offers control over those features. This is where the Capabilities tab of the camera template helps. If we click on the tab, we are presented with a list of camera features delivered through the camera template. Configuration of any of these capabilities is very easy. For example, let's configure this driver to support pan, tilt, and zoom, all features supported by our camera. Here is the Has Pan capability. Double-clicking on the capability name will open the Capabilities Edit screen. Adding support for this feature simply involves setting the value field to True and clicking Save. We'll set the tilt and zoom capabilities to True as well. While we're in the Capabilities tab, let's take a look at the Modes capability. Here is where you can define the image formats supported by your camera driver. As mentioned in the beginning of this video, by default, the camera template supports testing URLs for JPEG, Motion JPEG, H.264, and H.264i. This capability dictates which of these formats are listed in Composer Pro under the camera test screen and under the image view for the camera. Listing the supported image formats for your camera driver in Composer Pro is as easy as removing the formats that are not applicable and saving the updated modes capability. Note the spelling and formatting used in the value field here. Removing or re-adding format types in this field must adhere to what is displayed by default on the Capabilities Edit screen. Setting the appropriate capabilities to support pan, tilt, and zoom functionality is the first half of what's required to add these features to our camera driver. Now we need to go into the Codes Commands area and update the corresponding proxy commands to complete the implementation. We'll use the pan functionality as an example. Panning has three components: pan right, pan left, and pan scan. In this video, we will not address pan scan. Here is the pan left proxy command. Updating the code for this command is rather simple. The local query string line is the only line of code that requires modification. A string needs to be placed within the quotes that represents the camera's protocol command for panning the camera in the left direction. By referencing our camera's protocol documentation, we know that the following string is assigned for panning left. This string is entered between the quotes for the local query string. Our code for the pan left command now looks like this. You will need to enter the correct protocol strings for the functionality that you have designated as true in the capabilities area. In our case, we'll go ahead and update the pan right, tilt up, tilt down, zoom in, and zoom out commands. Now we'll update our driver's main screen to reflect the changes we've just included. We'll increase our version number to 2 and update our modified date as well. We can also add some notes to help us remember the changes we included in this version. Finally, we'll save our updated driver. If we go back into Composer Pro and right-click on the camera driver from within the system tree, we see that there is an option to update our driver. Selecting that will overwrite the old one in our project. After doing this, it is necessary to restart Director. We recommend restarting Director through the System Manager utility within Composer Pro. To open System Manager, click on the Tool menu option and select it. Next, connect to your controller. Now you will need to close the current Composer Pro session. Click on the Status tab in System Manager. Locate and select the Director instance from the list. click the Disable followed by the Enabled button. Next, restart Composer Pro and connect to Director. Once connected, our latest version of the camera driver has now been loaded. To test our capability changes, we can double-click on the camera driver from within the project tree. We'll want to make sure Image View is set to MPEG or H.264. We can now use the pan, tilt, and zoom features of the camera. This concludes the template-based camera driver video. Keep in mind that you may find features in your camera that are not explicitly supported by the camera proxy. These features can still be supported by using custom driver properties and device-specific commands. These topics have been covered in previous training videos if you are not familiar with these concepts. We hope that you found the information presented here informative and helpful in assisting you with developing Control4 drivers to support IP cameras.